Thought I'd help you out with a couple of homework problems on this page from the homework from section 6.2. And these are a couple of graphing problems. So the directions tell us to find the zeros of the function and then graph the function. All right, so hopefully you can see that this function is already in factored form. So that makes finding the zeros pretty easy. My zeros are x is 0, x is -5, and x is +8. So I'm going to begin by plotting those three numbers on the x-axis. Again, another way of saying these are zeros is to say that these are x-intercepts. All right. So those are my zeros or x-intercepts. And now to find out, remember, I'm going to begin by trying to figure out what happens in this range in between the x-intercepts. So I'm going to start over here between the x-intercept of -5 and the other one of 0. And I'm just going to pick a number for x in between. I'm going to pick -2.5, and I'm going to plug -2.5 into this function for x and see what I get. So my input is going to be -2.5. I'm just going to get my calculator ready. And if you wanted to, you could go ahead and multiply this out and get it in standard form, and you could use that form if you wish. It really doesn't matter. So let's see, we got -2.5 for x times -2.5 plus 5. I think I'm going to move this so I can have a little bit more room. Let's put it up here. -2.5 times -2.5 plus 5 times -2.5 minus 8. Okay, so get your calculator and multiply that out. And I'm still plugging in. All right, and I get a pretty big number. I get 65.625. So obviously that's much bigger than my graph can hold. So I'm just going to treat these just the y-axis. I'm not going to change the x. I'm just going to leave those in terms of 1. So I'm going to say that the y-axis is in tens. So when I let x be -2.5, which is about right here, I'm going to go to 65 and almost 65.5. Okay, so we'll just show the ordered pair over here, -2.5, and I'm just going to round it to 65.63. All right, so -2.5, and then 10, 20, 30, 40, 50, 60, and it's really about a half. Okay, so that tells me that my graph, and now we know, since we've got to come through this x-intercept, then my graph is going to come up to this point. And we call that, we'll talk more about this phrase later on, but that's considered to be a relative maximum. I mean, if you think about it, we talked earlier how that this graph on the right side is going to go up forever. Okay, so we can't really say that it has a maximum of infinity, positive infinity. We just say, relatively speaking, this point represents the maximum. All right, so it's going to touch this point and come down. Okay, well, how far? Where do I where do I get to until I eventually come back up through this other x-intercept? Well, that's where we're going to pick a number. We could pick any number we want. I want you to understand that. We technically could choose any number we want, but just for making this a standard exercise, trying to keep everybody's graphs somewhat the same, we're just going to choose a midpoint. We're going to choose a number right in between 0 and 8, and that would be obviously 4. So let's see what we get for y when we let x be 4 in this function. Okay, so we get 4 times 4 plus 5, which is 9, times 4 minus 8, which is negative 4. So 36 times negative 4, another big number. I believe that's negative 144. Okay, so negative 144. So once again, your graph is a little bit smaller than mine, so it's okay if you want to make a few more marks at the bottom here, but here we are at positive 4. And I'm going to go down basically 14 and a little bit more. Way down there. All right. It touches that point, and then it's going to bounce up. So if this was our relative maximum, this is called our relative minimum. Whoa, starting to drift. Let me see if I can fix that a little bit. You probably get the picture. And we talked earlier about end behavior, why this will go up forever on the right. It's because my lead coefficient, if I did multiply all this out, you probably could see that the lead coefficient would be positive. And hopefully you see that the fact that I have 3 x-intercepts or 3 zeros means that this is a cubic function. And so the degree is odd, which means that the left side of this function will do the opposite of the right side. So that would be your rough sketch graph without using a graphing calculator, just doing a rough sketch. Picking a few points in addition to our x-intercepts. That's what the graph of this function would look like. All right, so let's just try one more. This is number 20, and same instructions. We're going to plot the zeros, or the x-intercepts. We have negative 1, positive 1, and positive 2. Okay. And what I'm going to do, just to make it easy, we know that to get a y-intercept, that's another point on our graph, whenever we want to know a y-intercept, we always let x be 0. Okay, to get an x-intercept, we let y be 0. To get a y-intercept, we let x be 0. All right, so we just did this part. We let y be 0, and we found out what number in each binomial would create 0. Let me write that out again. Okay, so that was easy enough. So now let's just get the y-intercept by letting x be 0. And that's just another easy way to plot a point on this graph. So 1 times negative 1, of course, is negative 1. Times negative 2 is positive 2. So I know that the graph has to cross the y-axis at positive 2. Okay. All right. So I know as far as end behavior, once again, we know this is cubic. We know the lead coefficient is positive. So I already know basically what's going to happen on the ends. And so I've got a pretty good idea what's going to happen in here. So I know this much. I know I've got to come up to this point as a relative maximum. Now what I don't know is what is my relative minimum. Once I cross through this x-intercept, I'm going to go down to a certain point, but I've got to come back up to get through this x-intercept. The question is, how far down do I go? Well, that question can be answered pretty easily by just picking a number to enter for x that is right in between. Okay, so let's just plug in 1.5 into our function for x. Okay, just substitute 1.5 in for x. And if you need to grab your calculator, that's fine, but this is 2.5 times 0.5, and this is negative 0.5. All right, so let's see what we get. Get negative 0.625, which is not quite 1. It's a little bit more than a half. So I'm going to estimate it to be about right there. Okay, excuse me. All right, so that tells me I'm going to get to this point when x is 1.5, y is negative 0.63. That's my relative minimum, and then I bounce back up through that x-intercept, going up forever on the right, which means since it's cubic, I'm going to obviously have to go down forever on the left. Okay, so just to show again a little more clearly, the x-intercepts, we found a y-intercept. We just basically picked the number in between these to tell how far up this function is going to go before it comes back down. So we chose 0, the y-intercept. And then we picked this number 1.5 to tell what the relative minimum is going to be. How far down is it going to go before it comes back up? And you can just kind of guesstimate where you think 0.63 is, negative 0.63. Okay, so that's your graph for number 20. I hope that helps you out. And if you have any questions, just let me know.